very experienced person and from a reputed institution in India which deals with environmental and climate change studies. I went through the activities of Anna University Center for Development Environmental Studies. It shows that they have some international funding from Germany and other countries associated with UGC, DST, and other agencies from Government of India, which are funding climate change and environmental studies for Anna University. They also have memorandum of understanding with several institutions, which shows that they are doing, the pioneering level of research in climate change and environmental studies. We are fortunate enough, actually, the STRIDE, a project of Central University of Tamil Nadu is fortunate enough to get the acceptance of Professor Painivelu to talk on mitigating climate change today. He is also the STRIDE advisory committee member and other participants. I welcome you all for this second special lecture on climate change. Now I request Professor Painivelu to make his presentation for close to 40 minutes, and then we will go for a little bit of clarifying doubts and suggestions, and then we will wind up the session. On behalf of Central University of Tamil Nadu, STRIDE cell of CUTN, I welcome you, sir. Now you can make your presentation, and it will be recorded. Thank you so much.
Good morning to all of you. Thank you, Professor, for the kind introduction about me as well as our institute. First of all, I want to congratulate you and Central University of Tamil Nadu to organize this program, and especially it is not new to me. Your friend Professor Ilangovan already organized. Commerce Department is also taking lead in this one, and we're continuing this, because ultimately everything boils down to economy. That is a commerce. Okay. That way, we were in center for institute also doing this. The topic I have selected today is about mitigating climate change. All of us are knowing it is not new to this. Our earth is getting warmer. Sometime back, there is an argument, even summertime it will be warm, all those things. But if we consider the average warming, it is going up. There is a scientific evidence is there. The atmospheric temperature, both atmosphere as well as sea surface temperature is warming up. And due to this, the climate is changing faster than ever before, because we put a lot of carbon dioxide and other greenhouse gases in the atmosphere, and ultimately warming and the consequent climate change is taking place. Actually, now, if you look at it, we are living in the age of climate change extreme events. The weather events like rain, storms, hurricanes, cyclones, everything is all in the extreme category. That is, with the bigger it is taking place. Even rainfall in a single day, it is very normal nowadays. Even Tamil Nadu last year, we witnessed 90 centimeters rainfall and avalanche in a single day. That leads to consequent flood. Even Chennai 2015, Chennai was flooded due to about 50 centimeter rainfall in a single day. So these are all common nowadays. Similarly, cyclone, Gaja cyclone devastated Tanjavur, Nagapattinam area, including Tiruvallur area, but I experienced this. And also the current increase in diseases. So now COVID-19 is there, new kind of disease is appearing. All these things is because of global warming and the consequent climate change. The curve clearly shows how the concentration of carbon dioxide in atmosphere is going up. It crossed already 410 ppm. Last year itself, it crossed. So what are the consequences of this climate change? Is one thing is sea level rise. Because of warming, and warming leads to melting of ice, all these things. So all the melted water ultimately reaches. Even thermal expansion is taking place. So these two ultimately leads to the sea level rise. Every year 1 to 2 millimeter is going up the sea level throughout the globe. And as I mentioned, the extreme weather events, that is very high rainfall and no rainfall also ultimately affects the food production. Okay. And we don't have, especially developing countries, we don't have proper mechanism to manage this. ultimately developing countries are most affected due to this change in climate conditions. Even summertime heat waves. There is again many people are dying because of the heat waves. May, June, that is very common nowadays, and water and food shortage because of the climate change. So also one of the common nowadays. And also, if you look at some of the plant materials as well as animal species are shifting their places. They move to better where better climate is available. They have started moving, and also uh, there is a risk of extinction too, and many species are disappearing from this. So these are some of the consequences which ultimately, if you look at it, affects the food production. Ultimately, that is what very important. So we have to manage this climate change. There are two ways we can do this. One is mitigation of climate change. Other one is adaptation to climate change. So the mitigation, we have to do something. All this greenhouse gases, carbon dioxide, and other thing, what we emit into the atmosphere should be stopped. Then we can, because all these greenhouse gases, including carbon dioxide, the moment it goes to atmosphere, what happens is they absorb the IR light, infrared radiation of electromagnetic spectrum, and absorbing it and converting it into heat energy. So all these greenhouse gases, which have permanent dipole moment like carbon dioxide, methane, nitrous oxide, etc., they absorb carbon dioxide and other things, convert this light energy, especially the IR, infrared portion of this electromagnetic radiation, and convert it into heat energy. That is responsible for this global warming. So the carbon dioxide and other gases goes up in the atmosphere. We continue to put a lot of things. Ultimately, that raises the temperature of atmosphere as well as sea surface temperature go. And before industrial era, if you consider till now, almost close to 1 degree Celsius rises no case and gets concentrated in one particular place. That is what we're witnessing extreme rainfall events, etc. So more evaporation from sea and other water bodies and gets condensed everything at one time. Ultimately, that brings in very high rainfall, and that we are not able to store it. Our infrastructure, if you look at it, we are all designed mostly including stormwater drain, 30 centimeter rainfall in a single day. Suppose we get more rain and we are not able to save everything ultimately in the sea. So this is one of the main issues. So the chemical species responsible, look at it, it is all carbon dioxide mainly, nitrous oxide, methane also, but the main culprit is carbon dioxide. See where it comes, mainly burning of fuels, coal and other fossil fuel, whatever we use burn, ultimately converted into carbon dioxide that is emitted in the atmosphere. And that is the main thing. So what we can do, and globally, many people agree to minimize this. So as I mentioned before, there are two ways to increase this climate change. One is mitigation, mitigating the emission of carbon dioxide and other greenhouse gases, and the other way adaptation. Adaptation means dwelling situation, and we have to live with the condition, adjust the condition, and live with it. And today, I plan to tell you something more on about mitigating this carbon dioxide. And that is the main culprit that is responsible for this. What are the sources, main sources of emission? Thermal power station, where coal is used, and that emitted coal is liberated in the atmosphere. That is the main thing. Similarly, other burning, whatever fuels we burn, including cement industry, steel industry, etc., they emit huge amount of carbon dioxide. Ultimately, everything goes up. Same way, our transportation sector, we use a lot of vehicles, two-wheeler, or auto and four-wheelers, everything emits carbon dioxide. Not only this, even incomplete combustion leads to what is called black carbon, soot particle. That is also climate warming force material. Next to carbon dioxide, the black carbon is the main issue which is responsible for global warming. So we have to mitigate this emission of this carbon dioxide and other greenhouse. How we can do it? If you look at the sources, mainly come from stationary sources like cement industry, steel, thermal power station. And really, if you look at it, we are going to have this fossil fuel for another 30 to 40 years, definitely. So till that time, this type of technology will develop, that is thermal power station. And basically look at it all in a stationary place, everything. So if you try to capture this carbon dioxide and use it, that will be a very good result. And Government of India also committed to the United Nations. There is IPCC meeting, and Government of India committed two ways we are going to mitigate this carbon dioxide. One is going for renewable energy and improve the efficiency of the electricity. Renewable energy, solar, especially in India, we have sunlight, plenty of sunlight, almost available throughout the year. So that is a very good source. So we go for solar, that is possible. Similarly, other options are wind energy and hydro, water, dams and everything, it can generate energy. So all these renewable sources, especially solar, Government of India committed, and by end of 2030, we'll be going for nearly generation of 175 gigawatts of energy for our use. But definitely, if you look at all this process, no emission of carbon dioxide and other greenhouse gases. Everything is normally benign process, and that is what Government of India committed. We will reduce the emission of carbon dioxide by slowly switching over to renewable resource, and by 2030, we will be generating about 175 gigawatts of energy. So that means it's a huge amount of carbon dioxide saved. Similarly, government also going on here not against nuclear. Nuclear, there are some risks, but if we manage it properly, the radioactive waste, then it is again, there is no emission of carbon dioxide, nothing. So that is also considered to be a good chance. So like this, government will go for this type of renewable energy focus. The other one is going for increasing the green cover. Nearly 2.5 to 3 billion tons of carbon dioxide Government of India plan to sequester through by capturing this carbon dioxide in the atmosphere. So these are the two ways Government of India committed. So definitely by this 30 to 35% of carbon dioxide what we emitted when compared to the base year 2005, definitely it is possible by these two means to reduce about 35%. It is possible. Still, if everything is feasible, we may go beyond this committed also. So this two ways. One is switching over to renewable energy. The other one is increasing the forest cover. And mostly from academic institute, we also have a scheme called One Student, One Tree that also contribute to mitigation of this carbon dioxide. What happens is ultimately carbon dioxide in the atmosphere is converted into glucose and other ingredients later on subsequently. To this green cover, that is a natural way of sequestering carbon dioxide. So this is what our India commitment. But I think in my opinion, we got to go beyond this. Okay. Then only we can achieve the target of 1.5 degree rise restricted to below 1.5 degrees Celsius rise by the end of the century. Okay. That is what globally everybody is attempting. At least even if it is not 1.5, at least 2. But majority of the countries agree to take this mitigation measures actively so that we can restrict the rise in temperature below 1.5 as possible. So that as Commission and other countries also, especially European countries, they are also committed to go beyond this. And many European countries, they go for carbon dioxide sequestration, CCS call it, carbon capture and storage underground. because this global warming issue is there only carbon dioxide present in the atmosphere. Suppose all this carbon dioxide put into the atmosphere underground, definitely it is not going to create any trouble. So that way, many European countries are going up. But in my opinion, there's a small risk associated with carbon dioxide, even though more or less stable compound, slightly acidic in nature. It has a tendency to react with other minerals, especially calcium containing calcium carbonate. It can convert the calcium carbonate into water soluble calcium bicarbonate. The hardness may go up. We don't know what is the long term risk of this. Better option will be going for capturing this carbon dioxide and utilizing it into various value added compounds. Okay. Especially Thomas Deformidis organizing this, I want to stress nowadays, all of you are familiar with what is called circular economy. And compared to the conventional way of a linear economy, now everything is a circular economy. That's one of the sustainable development concept. And in chemistry, we call it as a green chemistry concept. There is no generation of waste or toxic compound or hazardous material used in any of this process. So that is what green chemistry or sustainable chemistry. No use of toxic or hazardous substances. Everything is renewable source, and ultimately there is no harm to the environment. Similarly, here also this energy generation and carbon dioxide emission. Now we have to go beyond this, and there is an option called what is called carbon capture and utilization. And this goes very well with circular carbon economy. This circular mode of economy, anything what is waste, we have to recover. We should not, whatever waste is comes there, it is definitely a useful material. Now to do something to recover it and use it as an ingredient or raw material. So similarly, if you look at the nature of the carbon dioxide, it is again very valuable chemical material. So this carbon, whatever emitted as a carbon dioxide is captured and utilized properly, we can achieve this circular carbon economy. So we can do this. If you look at carbon dioxide, there are two ways we can use it. One is direct use of carbon dioxide. I'm very sorry because I could not able to show the slides. Somebody blocked my slides, no issues. So two ways the carbon dioxide we can use it. One is direct use of carbon dioxide. The other one is convert this carbon dioxide into valuable material and use it as a resource. So that way we can achieve a circular economy of this carbon dioxide. So what are the direct uses? I hope all of you must have seen the fire extinguisher. The red cylinder, small cylinder, handy cylinder. It is filled with carbon dioxide. It is one of the valuable fire extinguisher. It will put out flame. So this is one way. And also we might have taken all of us ice cream. Ice cream is stored in a box container, and that is nothing but dry ice, dry carbon dioxide. And these are the day-to-day example we witness of using direct carbon dioxide. There are other ways industrially to be useful. And the main thing is as far getting oil extraction, enhanced oil extraction or enhanced gas extraction is possible, like methane, etc. Wherever the oil field and gas field are there, and we collect this carbon dioxide, pump it inside the field, carbon dioxide will go into the deep aquifer and liberate oil and as well as methane gases, I think. So that we get enhanced amount of this oil as well as carbon dioxide. These are the direct use of carbon dioxide. The other use is carbon dioxide. Another wonderful special chemical, what is called, it possesses supercritical property. That is, at a particular temperature and pressure, carbon dioxide will coexist in gaseous form, liquid form, and solid. And this supercritical condition, it has a very special property of dissolving all substances and removing dirt, everything. So it is used industrially as a supercritical fluid extractor in which it can extract very good amount of chemical, including coffee. Caffeine, if you can want to extract, it is possible to isolate caffeine out of it. Similarly, this will be the future our washing machine because of climate change, water availability, agriculture, all this is a problem. Water is in question mark. Even for washing, we may not have sufficient water at home. And sometimes in Chennai, we face this issue. Sometime back, water shortage in summer times is a very, very serious issue. So under these type of critical conditions, use carbon dioxide in washing machine, the supercritical fluid technology, definitely everything is a kind of dry washing type of thing. And then all your dirt will be removed out of the fabric. So this way, future already trials are made. Future one day, all our washing machines maybe they're made with carbon dioxide based one. Similarly, industry. Carbon dioxide is a slightly acidic gas where alkaline base is there. And one of the requirements is you have to neutralize the pH below 9.2 by using carbon dioxide. You can bring the pH from alkaline range to below 9.2 or less also near neutral. So like this being, carbon dioxide is a wonderful chemical. We can use it directly without any conversion. Even in plating industry, to remove oil and grease, carbon dioxide again, wonderful cleaning material. So like this, it has plenty of advantages for direct application, which has a lot of economic value. And more importantly, carbon dioxide can be reacted very easily with a variety of chemicals and gets converted into more value-added products. That is possible. One of the simple example is our well-known fertilizer urea. Urea is made from reacting carbon dioxide and ammonia. So ammonia, if it is reacted with this waste gas, carbon dioxide is separated from the stationary source or put a urea plant, manufacturing plant near the thermal power station or wherever carbon dioxide emitter in a huge amount, definitely we can capture this carbon dioxide and react with ammonia and convert it into value added urea. Similarly, plenty of chemical, formic acid, even including our aspirin. Phenol is reacted with carbon dioxide, get salicylic acid, that is converted to aspirin. So like this, many chemicals, including carbonate, polycarbonate, everything is possible. Right? So reaction with this. So lot of scope is there. Already urea is happening. And one of the thing is, right now what is happening is urea manufacturing carbon dioxide is getting from limestone. Limestone, there is calcium carbonate is taken, heated to liberate carbon dioxide by spending a lot of thermal energy. You want to heat it above 450 or something. Okay. So there are variety of chemicals we can make out of this carbon dioxide by reacting with this. And in fact, I had a slide indicating all this chemical what we can make out of making use of this carbon dioxide. Unfortunately, I'm not able to show the slide. Somebody blocked it. So starting from urea, simple formic acid, even there is a possibility of getting methane. Carbon dioxide under ideal conditions, we reduce it, the hydrogen, it will be converted to methane. Again, we can burn it. That option is there. But again, the energy consumption, if it is managed through renewable sources like solar, wind, etc., and one of the thermodynamic limitations with this carbon dioxide can be managed. Because there are now electrochemical and photochemical methods are available to convert it at all their require energy. Because carbon dioxide is thermodynamically stable material, and suppose we get the energy with this material through renewable energy, and we can very well convert all this carbon dioxide into different variety of value-added chemicals. So that is possible. As I mentioned, from starting from direct use of carbon dioxide is possible in certain applications, and other applications like urea, carbonate, and other variety of including methane it is possible to obtain this carbon dioxide. So this carbon dioxide capture and utilization is another way of managing and or a partial way of managing carbon dioxide, because mitigating carbon dioxide is a huge amount. It has to be attempted in all ways, and definitely, in my opinion, carbon dioxide to this circular economy mode, that is recover, reuse options, definitely the 4R concept, reduce, recover, reuse, or recycle in whatever form, definitely that will add value to this ongoing activity of climate mitigation. In this way, this also definitely is possible. So to sum up, if you see another 30 to 40 years, this thermal power station or cement and steel industries are going to be there using conventional fossil fuel. As long as these are there, definitely carbon dioxide emission is going to be there. And also, overnight we cannot shut down all of our thermal power stations and other industries which uses fossil fuel. Slowly we have to switch over to renewable, more city of renewable energy and other way of environmentally benign process of energy generation. But till that time, we have to manage it. Okay? One is naturally through sequestration, through photosynthesis, natural way. I forgot to mention, even I made the slides and all. One of the other way is algae. Well, especially countries like Japan, South Korea, China, they manufacture a lot of edible algae from seaweed and other things. Wonderful protein material, and this way it can be encouraged. Algae, not only the edible material, lot of medicinal value materials can be isolated pharmaceutically. Active ingredients are present in this seaweed and other algae material that can be isolated biologically using engineered system. Speed up the process. Possible and chemically also. A lot of ways are there. So this should be paid